average rate of change, okay? And here's our function s of t, and that's the rock dropping off the cliff. All right, so let's look at it again, and of course we could certainly find the average rate of change again, maybe from 2 to 3. Let's do that. So I'm going to go with green again, that's what I used last time, make it a little bit thicker. And I'm going to say, we're going to go, well, let's go from 1 to 3. From 1 to 3, what's the average rate of change? And so I make my secant line. Here's the secant line. And the secant line, well, it's pretty close. I imagine it's going through at x is 1, or time is 1, and time is 3. And so our points are at time 1, oops, go back to black. At time 1, this point here, what's the distance? 5. And then at time 3, we know the distance is 45, right? And this is an AP question, by the way. You'll be given a curve and you'll be given an interval, and you need to find the average rate of change. It's the slope of the secant line, right? And so, of course, it's going to be 45, right? And this is an equation for slope, remember? Yeah. Right? y1 minus y2, right? 45 minus 5, oh, come on, 5, over, but I stay in the same direction, 3 minus 1, and of course this is going to be 40 over 2. Oh, it comes out as a nice number. And it's 20. 20 what? What? What is it? 20 what? Let me move this down. 20 meters per second. Right, thank you. Make sure you guys are awake. 20 meters per second. Okay, so let's take a look. We were going 5 meters per second. Oh, we're going 15, you're right. We're going 15, and now we're going 20. What's going on? What's happening? What's happening? What's the word? It's accelerating. How fast is it accelerating? Ooh, how fast? I'll give you a hint. Gravity. 9.8 meters per second squared, and we approximated it. So it's actually accelerating, right? As a matter of fact, let's take a look at how is it accelerating, okay? So I'm going to, in black, draw the different slopes, right? So initially, at time 0, it's not moving at all, right? So there's the velocity vector, so to speak. I don't know if you can see it very well. I did it in black. At time 1, there's the velocity vector. There's the velocity vector at time 1, right? At time 2, here's the velocity vector, right? And at time 3, there's the velocity vector, right? So those are actually how fast it's going. The slope. You follow what I'm saying? Let me just. Yeah, we have an alarm going off in the background. We'll ignore the alarm. Okay. So these are just to mark sort of a grid, right? So here are our points, let's see, at time 1, at time 2, and time 3, okay? At these points in time, the rock is going a certain velocity, and that velocity is the slope of the tangent line. You follow what I'm saying? The tangent line would be the instantaneous rate of change. So these are not secant lines. These lines I have drawn that you see here, they are tangent lines. All right? These are tangent lines. Does everyone see how a tangent line, the slope of a tangent line, is actually the instantaneous rate of change?
Attention, teachers and students.
I think we'll stop right here.
In case any of you hear it, there is a